Alright, so in this video we're going to solve this equation that contains two radicals. And so when I have two radicals, the best I can do is to isolate one of the radicals. And so I'm going to choose to isolate this radical, which means subtract that one from both sides. And once I have a radical by itself, I can square to remove the radical, and I just need to make sure I square on both sides. So this square root and this square undo each other. And on this side of the equation, remember that exponent means multiply this expression twice. So I'm going to need to use my FOIL method to simplify that. Right, so I've still got 3x plus 7 on the left, and if I do my FOIL method over on the right, multiplying the first two, I get 1. On the outside, I get negative root x plus 2. On the inside, I also get negative root x plus 2. And when I multiply root x plus 2 and root x plus 2, I get just x plus 2, and this term are both negative, so when I multiply, I get a positive. Now over on the left, I can combine some terms. I've got a 1 and a 2, which add up to 3. I've got this radical and this radical, which are like radicals, so I can add their coefficients, or in this case, it would be subtracting negative 1 minus negative 1, which is negative 2 root x plus 2. And then there's this plus x still hanging out at the end there, and I still have 3x plus 7 on the other side. So now I'm down to an equation that has just one radical, and so my goal should be to get that term with the one radical by itself. So I'm going to subtract x and subtract 3 off of both sides. So that's going to give me 2x plus 4 equal to negative 2 root x plus 2. Okay, now I could go ahead and, since this negative 2 is multiplied by the radical, I could divide by negative 2, and that would be fine. However, at this step, I'm going to go ahead and square both sides. And so, on my left side, I'm going to have to FOIL again. And on the right side, I'm going to have negative 2 squared, which is 4, and square root of x plus 2 squared, which leaves me with just x plus 2. So I'll assume that over here on the left side, you're okay with doing the FOIL method. First outside, inside, last. So let's see, I'm going to have 8x plus 8x on the outside and inside, and then plus 16. And on the right side, if I distribute the 4x plus 8. And this is a quadratic, so I want to have this equation equal to 0. So I'm going to subtract 4x and 8 on both sides. So what? I've got 4x squared plus 12x plus 8 equal to 0. And each of these terms contains a common factor of 4. So I wouldn't have to divide this out, but it's certainly going to make our life a little easier in trying to solve this quadratic. So I'd have what, x squared plus 3x plus 4 equal to 0. I'm sorry, I made a mistake here. I thought that something didn't look right. 8 divided by 4, of course, should be 2. So that looks much better because now this factors. And we get 2 answers. And of course, anytime you solve a radical equation, you have to remember to check your answers. So if I plug -2 back into the original equation, right, so going back to the very top, let's see, x plus 2. So what does this give us? This gives us the square root of -6 plus 7, which is 1, plus the square root of 0. And that does, in fact, equal 1. And if I also check -1, going back to the original equation, let's see, that's going to be the square root of 4 plus the square root of 1, which I don't think equals 1 because that's 2 plus 1, which of course is not equal to 1. So x equals -1 is not a solution, and we have just one answer, x equals -2.